All right, so I'm going to do a couple example problems. I will say that, again, for those of you watching this, this section right here, that's all you'll need to do for those down there. All right, so it's pretty much just the top two rows, this section at the bottom. This will be optional. All right, so just worry about kind of what's highlighted in green here. Because if you can get those, then you should be fine with the bottom ones. So remember, your goals are to, for all of these, figure out the increments of measurement that each line represents. And in this case, it is not 1. All right, each increment actually represents 2 milliliters for that one. All right, now because of this, when we look at our measurements, we're reading from that meniscus there at eye level. We want to figure out, okay, well, what numbers do we know for sure? So we see that it's like right in the middle, right in the middle between what would be 24 and 26 milliliters, which means that, I don't know, this can go a couple of ways, but if it's right in the middle, then maybe I want to say that it's about 25. And if I want to say that's about exactly 25, then I would just add that single digit of estimation there. And I'll make sure I write increments so that you don't get confused saying that, oh, that's 20, why is that 2 milliliters? Over here, each one goes up by ones. All right, so this one's a little bit nicer. This seems to be right at 9 milliliters, so I would say 9.0 milliliters. So you can go on through that. Something like this down here. You look at each increment. Again, each line represents 1 in this case, if I went all the way from 0 to 10. And then this meniscus right here seems to be just above the measurement of 4 milliliters. So just above, maybe I might want to go 0.2 as my estimate. Again, you can do 0.1, you can do 0.3, but it wouldn't really make sense to do like 0.8 because the meniscus is not up above there. So you can roll through with the measurements there. And remember, this stuff is optional if you want. There will be a key with everything on it though later on. What part of the liquid? We keep talking about this word because it's very important. That's the meniscus. All right, so for our density calculations, remember, here's our triangle. Anything above the other, I divide. Anything next to each other, I multiply. So I'm going to do a couple examples of this. We should be pretty straightforward here. In this case, I'm looking for mass. So I would cover up the M, and I see that I have to take M equals density times volume. My density is 3. My volume is 100 milliliters. That means that I have 300 grams of substance there. And remember, units, units, units. I will be marking off if units are not included. Something like this one where we're looking for density. Well, density is mass over volume. I look at the triangle, or I can see that from my base equation there that we use. So the mass here is 950 grams. The volume is 95, which means the density is 10. Now, because this is grams up here and milliliters down here, that's where we get the units for our density of grams per milliliter. All right, and now we have volume to solve for. That's kind of like in the example problem. Volume is going to be equal to mass divided by density. Using our triangle, 20 divided by 5, and it gives me 4. And in this case, centimeters cubed is our unit for volume. Remember, centimeters cubed and milliliters are basically saying the same thing. So those are just a couple of examples to use. Something like part C, I'll help you set the first one up. You're looking for those units to make sure you know what you're looking for and what you don't have. Mercury metal is poured into a graduated cylinder. The volume is read, so this is V. So we have 22 milliliters. And the mercury is used to fill the cylinder. That weighs 308 grams. And then I want to calculate the density. So that was mass. Density is what I don't know. So I'm going to use that information and solve like I did above. All right, hope that helps. Thank you very much.